representing Dan Ames and Amanda Hughes, and I'd like to explain a little bit more about the project we have in the water and disasters thematic area in the SERVIR Amazonia hub. Our overarching proposal or project concept is to extend our global streamflow forecasting techniques and tools to flood delineation and impact in that region. We want to share the things we've already been working on and build on that. We have a focus on the goal of reducing loss and life of property due to flood damage. We want to investigate also the use of social media and other satellite products to add value and validate the work that we're doing. And we hope to team across the SERVIR Amazonia hub and the water and climate thematic areas so that we can make more out of the tools that we have in working together. This is part, of a larger project also funded under NASA GEOGIOWS. We use Tethys, and I have a separate application or presentation that kind of shares a little bit more about that in order to create web applications of Earth observations and model data. The thing that we've particularly been working on here at BYU is a global streamflow forecasting project that produces both an ensemble forecast and a retrospective analysis, historical analysis to put that in context for every river in the world. It started in South Asia with ECMWF as part of a SERVIR project, but now is expanded under GEOGIOWS and this partnership to the rest of the world. The main concept here that we're trying to do is move away from having to provide the raw data and having every local government and NGO institution have their own model and infrastructure to provide that in order to create the information to make decisions, to where we can leverage these global large big data sets and modeling infrastructure and then provide services so that that can be combined with local efforts of observations, perhaps local modeling efforts where we have higher resolution, and create something that provides a web interface so that these decision makers have access already to good information to make the decisions that they need to make. Specifically with the global streamflow, we've worked with the European Center for Medium Range Weather Forecast. They generate a global gridded runoff data set. It's an ensemble runoff data set through their GLOFAST. We take that runoff and map it to smaller watersheds, route it through a river network, and then produce two important end services. One is both the historical and ensemble or probabilistic forecast that's produced on every river of the world every day for the next 15 days. And then in partnership with Esri, a flood map, or I'm sorry, not a flood map, but rather an animated map showing in space and time where severe events are occurring are developed. These two services can then be put together in a variety of different applications and used for downstream application. And the thing that we want to do in our project here is flood modeling. But this kind of shows that underlying global streamflow tool. This is, you can see it's run in all regions of the world. Here I'm going to zoom in and show an example in Africa. And you'll see as we move in, the rivers will appear. You kind of get an idea for the resolution of the river network that's being modeled, for which a forecast can be developed. And here we'll then select a stream. We can view the ensemble forecast for the given day, and it's probabilistic because there are a number of ensemble members. It's put in context by this 35-year retrospective analysis that helps us determine return periods that can also be used to examine the overall climatology or history of in that region. Now, as I mentioned, the powerful thing about this is that it's an API, so that here we have a Python library that actually gives us access to all of that code. So for this same reach ID, we're now querying the API where we can get both the statistical summary of that ensemble forecast as well as all the ensembles if we want. We could get any single member or all members of the ensemble. We can also grab the historical analysis that produces those return periods and retrospective analysis, as well as other information that's derived from that. So all that's made available through an API, which allows us to create additional applications. And so here's one we've already worked with EDM, one of the potential stakeholders and users in the Amazonia region. And we've combined with their historical observations a tool that allows them to compare to the simulated discharge from the global stream flow, and then be able to do different kinds of metrics on that so they understand how well it's working and any bias that might include, so that they know how to use that information. So this is a tool that was created with our Tethys application that kind of extends that base stream flow forecasting. Now, as part of our project here in the Amazonia hub, we want to extend the streamflow forecasting to flood maps, because as hydrologists we understand what a hydrograph means, but in order to make it have real impact for decision makers, we want to know where it's flooding and what infrastructure or who is being flooded, so that we can make a more informed decision. And we've already worked on some of these ideas using the height above nearest drainage methodology, which is a zero order kind of bathtub feeling way to do a flood mapping. We can take the flood discharge, and then using a digital elevation model be able to determine where that works, and we can do that for any ensemble, for the average, for the max, or for all ensembles. And this orange map here shows a probabilistic flood map that might occur from that. Now, in many cases where we have infrastructure and human intervention, this zero order hand method doesn't work as well. And so we're also going to investigate with our partners at Aquaveo, who manage the surface water modeling system, two-dimensional models that might provide better information in specific locations where we have that data and we understand what the infrastructure, how it's been changed, so we can better provide that for them. We want to combine this, as I mentioned, with social media, where we can harvest from Facebook, from Twitter, from other articles on social media where flooding occurs, so that we can help validate and provide additional information. And then finally, combine that with additional satellite data products. And many of you work in this area. We look forward to working with you and trying to incorporate that kind of information into the overall system, so that we have not only the forecast but the real-time monitoring situation as well. As I mentioned, we have developed a platform called Tethys that allows us to bring these big data and modeling cyber infrastructure through thin clients, so that we can create applications that are consistent and uniform for our end users. And that's what we've done with our applications. We hope to be able to partner with you and do more of that. So for this larger GeoGlows, we've developed a warehouse, if you will, and many different kinds of applications. This shows a GLDAS interface, and this is just a time series of netcdf files. It allows us to view them as an animation, but also to put a point down and then extract a time series at that location, or to aggregate over a polygon and extract a time series for the same. A very similar application is done with the global forecasting system developed by NOAA, so that we can look at meteorological forecasting again at a point or over a polygon. We can extract those time series and then use them in other applications. As part of another project in the previous SERVIR AST, we worked with Cedric David and also Yankee Lee in order to develop an interface that shows the GRACE information. And again, these are time series of netcdf files that we can extract at a point. Here, groundwater storage anomaly that's been generated by combining with the GLDAS data with the GRACE. So we did several other applications, and that's the idea. I created that other presentation about Tethys so that you might see perhaps it would be a utility that would be useful for you in getting your results out, but also in making it a consistent interface and location, as part of a warehouse where our end users and stakeholders might be able to pull together these applications in a suite of tools that do weather and climate, agricultural related information for their decision making in a consistent way within SERVIR. So we'll be talking more about that. I know that SERVIR is organizing some training as well for the hubs, and we're considering the idea of maybe having a boot camp or some kind of a consultation and training here at BYU sometime in the coming year. And we look forward to hearing back from you. We look forward to working with you and learning from what you're doing and helping to enhance what we're doing, and vice versa. Thank you so much.